Hello everyone, we are here to explain the video with the quantitative analysis chemistry course with the title infrared spectroscopy. Happy watching. We are from Group 8, consisting of B. Antothan Wayuni, Nabila Ramadani, Meteor D. Zakiathan. Infrared spectroscopy is a chemical analysis technique utilizing electromagnetic radiation 780 nm, 1 mm to measure molecular interactions. The principles of infrared spectroscopy are 1. Radiation irradiates the sample. 2. Molecules absorb radiation, altering vibration or rotational energy. 3. Undetected radiation is detected. 4. Data processing generates Earth spectrum. Types of Earth spectroscopy. 1. Transmission measures radiation passing through samples. 2. Reflection measures radiation reflected by samples. 3. Attenuated total reflection measures total reflection. 4. Fourier transformer FTIR analyzes data using Fourier transformation. Earth spectrometer components. 1. Radiation source. 2. Monochromator. 3. Sample. 4. Detector thermal photo. 5. Data processing system. Infrared spectroscopy is widely used in various fields for molecular identification and structural analysis. It helps detect functional groups in organic and inorganic compounds by analyzing their characteristic absorption pattern. Applications include quality control in industries such as pharmaceuticals and food, environmental monitoring for detecting pollutants like coal and methane, and biological research for studying proteins and other biomolecules. Additionally, it plays a crucial role in forensic science for identifying materials like fibers and paints. This non-destructive and efficient technique provides valuable insights into molecular composition and interactions. Infrared spectroscopy offers several advantages, including its non-destructive nature, rapid analysis, and high sensitivity to molecular vibrations, making it ideal for identifying functional groups and chemical bonds. It requires minimal sample preparation and works with solids, liquids, and gases, providing flexibility across various applications. Additionally, it delivers precise qualitative and quantitative data, making it valuable in industries, research, and environmental monitoring. Its ability to provide detailed molecular information without altering the sample makes it a powerful and versatile analytical tool. Infrared spectroscopy measurements are typically performed using transmission, reflection, or attenuated total reflectance techniques. In transmission, the sample is placed in the
Just like visible light, infrared radiation has a spectrum with a range of frequencies. Different types of bonds absorb different frequencies of infrared, causing them to vibrate. Some bonds actually don't absorb infrared at all, but we'll come on to why that is later in the video. There are a couple of ways to prepare a sample for an IR spectrum. We can't put our sample in a glass container because glass absorbs in the infrared spectrum. It would be like trying to take a photo through frosted glass. Instead, we use cells with metal salt windows, such as sodium chloride or potassium bromide. Depending on what our sample is, we can either dissolve it in a solvent such as chloroform, press it into a transparent disc with powdered potassium bromide, or grind it into an oily slurry called a mol with a hydrocarbon oil called nujol. Infrared spectroscopy is a relatively simple technique. When we run an IR spectrum, we pass a beam of infrared radiation through a sample. The beam then hits a detector, which is located on the other side of the sample. This detector measures the transmittance, or in other words, the percentage of IR that's still present after passing through the sample. A transmittance of 100% means that none of the beam was absorbed by the bonds in the sample, and so all of it hit the detector. A transmittance of 0% means all of the beam was absorbed by the bonds in the sample, so none of it hit the detector. Over time, we scan through different frequencies of IR radiation until we've gone through the whole IR spectrum. Depending on what bonds are present in the sample, different frequencies of IR radiation will be absorbed, so we see these inverted peaks across the spectrum. We call these inverted peaks absorption bands. The frequency along the x-axis of the spectrum is measured in inverse centimeters, or centimeters to the -1. You'll often see this axis labeled as wave number, which essentially means the number of oscillations per centimeter. This is directly proportional to the energy of the radiation, so high values of wave.
Thank you for watching this explanatory